Alright, very good morning. Today we will start with chapter 1, probability. I see here how many people? I see here 21 people. Supposed to be 20, 30 I guess, if I'm mistaken. 30 or 25, I'm not sure. Later I'll check who never attend. Alright, let us start with chapter 1 here, probability. I suppose you have learned this in the school, but here we will revisit again on the chapter 1. Okay, I have shared this slide for all of you and also tutorial exercises. Today we have time, we proceed with tutorial, otherwise we will see. I will try to manage other classes in other classes. Okay, all right. Now, some important terms. Random experiment. What is random experiment? Random experiment is if you do one activity, okay, you do something, and then that activity, if it comes out with several possible outcome, okay, to make things clear, if that activity comes with several possible outcome, then that is actually random experiment. That's the idea. Random experiment means if you do an activity and you only have one outcome, then that is not random experiment. For example, if you flip a coin here, how many possible outcome you can see? One is head, one is tail. So this is considered random experiment because you're going to either get a head or tail. You don't know. It's a random thing. But then if this flipping coin here, this flip coin, both sides are tail. What are the possible outcome you're going to have? Tail only. This is not random experiment. This is for sure you will get tail. Okay, clear? So random experiment means out of some activity, you must have some more than one outcome. Another example, record marks on statistics test. Okay, the test mark can be in between 0 to 100. So your marks can be 99, 55, 54. We don't know. Randomly we can choose anything. Same goes for this experiment. You can read yourself, and all these experiments you can read. So yeah, that's the basic idea of random experiment. Okay, we don't know. Random experiment means we do some activity, but we don't know, we cannot predict the outcome. Okay, but it has several outcomes, but we don't know what kind of outcome is going to come out. Okay, that is random, we call it. Exhaustive outcome means all possible outcome. Exhaustive means, for example, you have a dice here. I'm recording this class so that later I will share the YouTube link. You have a dice here. Okay, so in the dice, I don't want to put this first. In the dice you have 1 and then 2, 3, and then 1, 2 and 3, something like this, and 4, 5, 6, isn't it? So if you throw a dice, what are the outcome you can have? Okay, you can have 1, 2, 3, 4, 5, 6. If you write all the outcome here, okay, if you write all the outcomes, that means exhaustive. But if you write until 4 only, that is not exhaustive. Okay, that is not exhaustive because you still have some other outcome. So in an activity, exhaustive outcome means you have to write all the possible outcome until 6 here. Mutually exclusive outcome is no two outcome can occur to the same time. If you throw a dice and we're going to look at the number on top, okay, this number only. We're going to look with we're going to see on the top, okay, the top number only. If you throw and dice, you make get 1, you may get 2, you may get 3. You won't get 1 and 2 together. Okay, there's no such thing a dice have 1 here and then suddenly 1 and 2 here. No such thing. Okay, so each outcome appear one time, that is mutually exclusive. Okay, exclusive. It one outcome itself, it won't combine with the other. That is exclusive. Now, exhaustive plus mutually exclusive, we call that a sample space. For example, this whole thing is sample space. Okay, sample space. Don't worry if you don't understand now. When you do the exercises, you for sure you will understand. Okay, sample space means must be complete all and must be mutually exclusive. Okay, that's the idea. You plus this. Probabilities, I think suppose you know this. Probability we normally denote it by P, Px, something like this. This is always in between 0 and 1. This is something I think suppose you know. Simple even. For example, what is the, if you have a dice, okay, you have a dice here, 1 to 6, 1 to 6. What is the probability of getting 1? Simple even means only one event will happen. This is the probability of getting 1. What is the probability of getting 1? 1 over 6. What is the probability of getting 3? It is also 1 over 6. This is all simple even. Probability of getting 5, it is also 1 over 6. All these are simple even. Okay, I call it a single outcome. I call it this all single outcome. Single outcome means 1, 2, 3, 5, all single outcome. Single outcome. All single outcome probability. This is all this single outcome is actually simple event. Simple event means only one outcome here. Now event means, okay, event means I combine all the single outcome. If I even see here, if this one is one outcome. If I write now probability of odd number, I combine everything. 1, 3, 5, all are odd number. Odd number means this is I'm combining more than one single outcome. So how many odd number are there? 3 over 6, which is 1 over 2. This is known as event. This is event. Okay, this is single outcome. This is more than single outcome, which is odd. Odd can be 1, 3 and 5. 1, 3 and 5. Okay. that is okay, the probability of event. Later when we do the exercise you will understand. Okay, that is something about some important terms. Now we are moving to the next part, probability of combined events. Okay, intersection of events A and B. Okay, normally we write it intersection means A and B. Okay, in words we write it like this. This is also equal to this notation. Okay, if you learn set in the school, I suppose you guys are well versed on this notation. And this and this notation in mathematically we plus the probability. Sorry, is it plus? No. N means normally we multiply. Yeah, we multiply. Anyway, this multiplication later when we do the exercise we will use whenever it's necessary. For the time being, you remember N or intersection here. The intersection of event A and B is the event that occurs when A and B occurs together, both occurs together. Okay, if you draw a Venn diagram, this part is a, this is A, this is B, yeah? And the intersection is A intersect B, okay? And it denoted by this or denoted by like this, okay? The probability of intersection is called joint probability. The name for this probability is joint probability. Determinants of success among mutual fund managers. So we have data here. This is top. A1 means fund manager graduated from top 20 MBA program. A2 means fund manager not graduated from top 20 MBA program. This one they perform well, this one they not perform well, something like that. Okay, outperform does not outperform. Okay, something like that. You just imagine like that. All right, those who graduate from top 20 MBA program and they are doing well. Okay, they are doing well, the probability is 0.11. So this is actually an intersection between this and this. Okay, I think I better use blue. This one is an intersection A to B1. So P A1 and B1, I can write it as 0.11. P A1 B2, I can write it as A2 B1 is this one. A2 B2 is 0.54. This should be the answer for 0.54, 0.06, 0.29, 0.11. Okay, this is the thing. right, next one, marginal probability. Marginal probability, so you have to understand now this part here. You have to understand this is actually a not enough space for me to write n, so I use the symbol here. It's the same thing. You have to understand this is a1 b1, this is a2 b1. Now, for me, the marginal probability is computed by adding cross rows and columns. So now, if I plus this, okay, if I plus this, what I will get is actually, can you see here, this one, there's a A1 here, see both of this one, both of this one got A1 and A1. Okay, B1 and B2 is different, but this one I have A1 and A1. So when you plus these things, you will get A1 here. This is actually the probability of A1. Can you guess what I will get here if I plus by row? What I have here, I have A2 and A2. If you plus, you will get
2.
A2. Yeah, that is by row. Okay, by row. Now, if you go by column, you plus like this. What is the same variable you have there? B1 and B1. So you will have here PB1, something like that. And here what you have? B2 and B2. You will have, if you plus this, you will have B2. So that's the idea of when you plus the column, you will get this one and this one. When you when you plus the row, you will get this one and this one. When you plus the column, you get this one and this one. That's the idea. So if I give some time for you to copy first, understand first. Alright, now let us do the computation. So as I told you just now, row 1, if you plus, you should get 0.11 plus 0.29, you will get 0.4. That is actually probability of A1. So that's how you find. If I give you a table, okay, if I give you a table like this and ask you to find this probability and ask you to find the single probability, then that's how you find. That's the idea how to do this. Okay, copy first this one. If my writing is, you don't understand my writing, you just let me know. Yeah. Okay, so if you join, if you put the join and joint, if you put the joint mean the one with the end, that is joint, the one with end. Marginal is a single one, single, this is marginal probability. If you put together, this is the idea: 0.4, 0.6, 0.83, 0.17, and if you plus like this or like this, you will for sure you will get 1. That is the idea. All right, this is joint and marginal. Okay, joint and marginal. Now we are moving to conditional probability. For conditional probability, I suppose, I don't know whether you have gone through in the school or not. The probability of event A given that B is, okay. So for example, here B happened first, okay, we call it given B, okay, given B happened first. What is the probability of A? The formula is A and B over P over B. For example, I'm just giving an example here. The probability of you bringing an umbrella, okay, I put M here, umbrella. The probability of you bringing an umbrella maybe is 0.3, but the probability given today is raining, rain. What is the probability of you bringing an umbrella? So maybe it's increased, maybe 0.7, the probability. That's the idea. Okay, that is the difference. Huh? So this is single probability. given I mean in any day, no condition at all. What is the probability of you bringing an umbrella is 0.3, but here there's a condition. What is the condition? Today is raining. The condition, that's why it's known as conditional probability. Today is raining. What is the probability you bringing an umbrella? So it supposed to be, by logic, it must increase from the previous one. So that's the idea. What is the formula for this? You have to find this is not umbrella, this M. You have to find the joint probability of M and rain over the marginal probability of R. So if you can find this, then you divide, then that is the idea. Okay. The probability of even A given B, we write like this. Okay. The probability of even B given A. So this one happened first. This is happened first. This is happened first. Then only we are finding this one. So the formula is like this. Given A, what is the probability of B? Is then this one you can write it as. And I want to show you. I want to tell you something here. P A, the probability of P intersect B is actually equal to P B intersect A. Is the same thing, yeah. Okay. In other words, P A and B is equal to P B and A. Suppose that we select one mutual fund. Okay, suppose that we select one mutual fund at random and discover that did not outperform the market. So you choose one mutual fund from the previous table here. We choose any mutual fund here. This is the mutual fund, any mutual fund, and we notice that it does not perform well. Okay, does not perform well. What is the probability that a graduate is managing? Okay, so what is the given condition here? Let us write here, given condition. Given condition is fund did not perform well. Outperform. Okay, outperform is good, not outperform is not good. Okay, this is B2, just now, B2. Seeking probability, I call it seeking probability. What is the seeking probability here? This is, I use different color now. Top 20 MBA, seeking probability. It is managed by top 20 MBA program. Okay, this is our A1. So when you write here, how to write the notation? Given condition is B2, seeking probability is A1. So this is the formula. All you need to do is A1 intersect B2 divide by this one, this is 0.29, this is, how much is this? 0.29 and then 0.83. Okay, this is the answer. So you can write here, you can write the conclusion. Thus 34.9 . Thus, 34.9 percentage of all mutual funds that do not outperform the market are managed by top 20 MBA program graduates. Okay, so you can copy this one first. Forgive me if my writing is a bit untidy. I'll try to make it tidy. Alright, I suppose all of you have copied this. Later I'll share with you, don't worry. All this I share with you, but some part I deleted, isn't it? But it's in the video. It's recorded in the video. You can also see the video. Alright. So that is regarding mutual, okay, conditional probability. That is regarding conditional probability. Now, after we learn conditional probability, there's another idea or notion known as independent events. Okay, independent events. For us, so the idea goes like this. Okay, the idea goes like this. Let me put it in this way. Just now I told you, you bring umbrella. What was the probability? 0.3. And then I told you that if it is raining, the condition is raining, the condition is raining. Today is raining, and the probability you bringing umbrella should be, I told you, 0.7. So my question is, this value changes, isn't it? Why this value changes? Because there's a raining day. So this raining day influences you, okay, to change the probability, okay. So this one without raining 0.3, but when it's raining, it influences you to influence the probability of you bringing the umbrella higher, 0.7. So which means R influence you, R influence, okay, R influence M. There's an influence, ada pengaruh, ada pengaruh. This one influence M. Now what if I put here 3 now? Does it? See, without rain, your probability is 0.3. With rain, your probability is also 0.3. Is this raining day influence you? No. Actually, no. Whether it's raining or not raining, the probability of you bringing an umbrella is 0.3. Always going to be 0.3. So, this is the idea. If the number doesn't change, R not influence you, tak ada pengaruh. R ni tak ada kena mengena dengan you. Okay, therefore I call it as M and R are independent events. Okay, independent. Dia tak pengaruh. Ini line, ini line. Dia tak ada pengaruh dekat sini. Independent. Berasingan. Okay. So that's the idea. So the thing is, if PAB is equal to PA, okay, the first one, M sama. A dengan A kena sama ataupun B dengan B sama. If you want to show two events are independent, you can show this or this. Okay, okay, first condition, I put it a first condition here. For you to show two events are independent, either you show like this, okay, you find this one and then you find this one, see whether two probability are same or not. If it is same, then A and B not related to each other, independent, they are not related, tak berpengaruh, not influencing each other. Okay, or okay, if they are asking whether the events are independent, you can show this condition. Or another condition is you can also show like this: the joint probability is equal to marginal probability multiply the marginal probability of B. This also you can show either one of them. If you can show either one of them, then you can write two events are independent. Okay, copy this one first. Determine whether the event that manager graduated from top 20 MBA program. This was A1, and the event fund outperform. Fund outperform is B1. So is independent events or not? So you can do this. Find this one first. What is this? This is actually A1 B1. What is A1 B1 just now? A1 B1 0.11. A1 B1 0.11 and B1 is 0.17. A1 1. So if you do this, you will get 0.647. And what is the probability of A1 just now? I think that is 0.4. So you can see that A1 B1 is not equal to, therefore two events. I write here two events, so you can write A1 and B1 not independent. Okay, not independent. Copy this one first. Alright, now here what I did is I find A1 B1 equal to A1. Okay, I try to prove A1 B1 equal to A1. Here I try to prove this, but you can also try to, you can also do this. Try to prove b1 a1 equals to b1, can, same thing, but you will get the same result here. It won't be equal. These two things won't be equal. Whichever way you go, once you prove this one is not independent, if you do this like this also, it won't be independent. Okay, so you can go either way. One. Okay. All right. We will take a break for 10 minutes. We take a break for 10 minutes and then we continue from there onwards, because our class is until 12. So let us take some break. We will take until 10 minutes break and then we continue. I'll see you all after 10 minutes. All right, let us start again. Let's continue. Union now. Union. For union, this is the, for union there's or, okay, there's or be plus here. Okay, as I told you last time, union, the notation for union is like this. You intersection and like this is union. For and, for n in the what you call Venn diagram, you shade here. For union in the Venn diagram, you shade the whole thing. Okay, that is the idea. Now with this formula here, let us try to do this question. Determine the probability that randomly selected fund outperform the market or the manager. Outperform the market, fund outperform the market, I think is B1 if I'm not mistaken. B1, yes. Or manager graduated from, this is A1. So if I want to do this, B1 or means I can write it like this. You can write it, or you can put a notation here. Right, and then okay, this one will be 0.17, 0.14, and this is 0.11. .46. That should be the answer for this. Copy first. Okay, if you copied this, I give you some time. You try exercise 1 here first. You try exercise 1. I will show you the answer later. You try first. Exercise 1. If you guys have done, let me put this as A, B, C, D. You just type there done. Okay, just type in the chatting so that done like this. If you guys have done, so that I know how many people have done, I can show the answer. If you guys want to see any one of the notes on top, let me know also. I can scroll up. Any one of you done exercise 1? If you have done, type there done so that I can show the answer. Calculate the marginal probability. But before we go for marginal, what is this probability? This one? Did I? Yeah, okay, I'm sharing the screen. 0.4, this is actually joint probability of A1 and B1. This is joint probability, yeah? So each number here is a joint probability of B1, A2. This one is B2, A1. But we don't want joint probability, we want marginal. Marginal means we go by row and column. So if I go by row, if I say let me do A1 first. If I go by column here, then A1 is 0.4, 0.2, 0.6. So that's how you find marginal probability. Okay, now let me show the answer, see whether you get this answer or not. Okay, just have a look first. A, just now I told you what is A B C, A B C D. Okay, you can name it. Check the answer, or you want to copy the answer. Exercise 1, copy first. It's better for you to copy instead of taking a picture, because maths and stats need some writing, not reading. If you take a picture when you want to do the practicing, yeah? So better copy this one first. Copy A and B first. Take your time, copy A and B first. While you're copying, try to understand how to answer the question, how I get the numbers out. Have you guys copied this? Have you guys copied this? Anybody still copying this? Okay. Okay. Now, next question is: are these are the events independent? Not are the events independent or not? They never ask which events. They just simply said the events independent or not. So, since you have done A and B, as I told you, independent, not independent, what you have to do, independent, whether it's independent or not, you have to show whether if A1 B1, you have to show whether this is equal to A1. If it is if you want to write A1 B1, then you have to show it is equal to A1. You have to check whether it's equal to A1 or not. If A2 B1, you have to check with is equal to A2. So you have found this one. You have also found this one. The C should be easy. Just check. Okay. So if you notice, all are not equal. So I don't prefer you to write dependent. You just write here not independent. Use the word not independent. And for, I think for what they ask, this one also, D also you can use the formula, you can copy D and C. For D I did 1, the rest you can try, and the answer I have given here, try. right? I suppose you guys copied this, huh? Okay. Now this all done, huh? I suppose you guys done. Now this should be easy. Exercise 2 should be easy. Okay. Try exercise 2 now. You have copied exercise 1. Maybe just now you didn't do this properly because maybe I was doing too fast. Now you have the answer for exercise 1. Based on that, can you try exercise 2 here? Try first. This is the answer for exercise 2. You guys double check. If your answer is tally with this one, can you write there, type there, maybe done or something like that, or correct, something like that. If your answer is not same with me, then let me know. I suppose I changed my mind. Maybe you guys are tired. Because many of you are fasting, and maybe today we make it a short class. Okay. Maybe we when we meet face to face, then we make it as a long class. Okay. Long hours is suitable for face to face class, not online class. Okay. So maybe today we make it a short. After these exercises, we end up the class. Any later I will do some recording for your references. Okay, I will replace it later. Classes will be the I need to replace one class and tutorial. I will replace it later, but I also will share some recordings for you to go through. Okay, never mind. Do this one first. Exercise 2, check first. If your answer is correct, make it correct. Okay, we're going to do exercise 3 and 4 maybe, and then we end up the class. I suppose many of you are not responding. Maybe you are tired. I can understand that. Okay, don't worry. Only for 3 and 4. Just try to make it 3 question 2 first, and then we make it 3 and 4, and then we end up. Try to write this answer first. Try to check this answer. If correct means just type that correct or done, something like that. Okay, some of you have done here. How about others? Okay, some of you have done here. Good. As long as you get the idea, this is still easy part. All these are easy part. Should be you guys should know all these things. Easy part. All these are easy. Waiting couple of you still. I'm waiting for a couple of your answers. If at least 10 or 15 people have done, we can move on to exercise 3. Okay, I suppose.
Doctor,
Yeah.
um, compute BP
Compute. Kejap ah. Yang mana?
yang
Compute.
A1 or A2.
PA. This one yang ini ke? Yang
Ah,
ni. Okay.
yes.
Okay.
How you get zero?
Zero means sebab tak ada sini because here you can, this is intersection. This is the intersection. Is there any intersection between A2 and A1 is here? A2 and A1 is here. There's no common number for them both, isn't it? Like A1 and B1, they share a common number here. the thing intersect. This one and this one intersect. So I take this one 0.15 is um, the A1 and B1. Can you understand? But can you see A1 and A2 here? Anything A2 here?
Yes.
Do you see A2 here? For you, any number here? Nothing, isn't it?
Oh, okay, okay.
So that's why it's 0 then. I put 0.
Okay, thank you, Doctor.
Okay, okay. Good question, good question. Any other question you can ask? Anybody? If not, let us try the last two questions. Last two questions. Hold with me. I know all of you are tired. It's okay. Maybe next class onwards. Next week no class because Raya. Okay, next week no class. I will do some recording and send to you. Those who are free, you can see. But next week is already face to face. So face to face class should be okay for us. Okay, should be fine for us. Okay, exercise 3 here. Exercise 3. This is the exercise 3 and then this is the question here. Okay, try first. You guys try first. Try exercise 3 first. So wrong now mine. Try exercise 3. I will write my answer here also, but I give you some time, maybe 5 to 10 minutes. You try first and then I will write the answer here. Oh, I show the answer here. Proportion and probability is same thing. Never mind. Just write the probability. You can consider proportion as probability. Okay. Right. right, let me help you here, see whether your answer is correct or not. Find what is the proportion of purchases, what is the proportion of purchases paid by a debit card. Debit card is here, so basically they are asking probability of debit. Probability of debit is, as I told you, you plus the whole column. So those who have done this, that is good, you understand the idea. If you plus all, you should get 0.36. okay, that is the first one. The second one is, the second one I do here, okay, B I do here. Find the probability that a credit card purchase given as a credit card, okay, a credit card purchase given is a credit card was more than 100. Okay, so this is maybe a little bit complicated. Given is a credit card, out of the credit card, which one we spend more than 100? So more than 100 intersect with credit card over credit card. More than 100 intersect with credit card. More than 100, more than 100 intersect with credit. This one, credit is here. So more than 100 credit, take this intersection right here, 0.23 over credit card, over credit card, the whole thing. If you plus the whole thing, okay, you plus the whole thing, you write it here, that would be 0.47, and this answer should be 0.49. okay, B you should answer like this. And the last one is C. C is determine the proportion of purchases made by credit or debit card. So C or D. Okay. C or D. This will be PC plus PD minus PCD. For PC you plus all, no, this is what? Credit, credit is this one here, 0.47, and for debit just now we plus already 0.36, minus C and D. C is here, D is here, both are on the same side. Okay, nothing is here, nothing is debit or credit here. So when both are same side and they are asking intersection, basically that is 0. So question 3, this should be the answer. Copy this one. Once you check the answer correct, okay, if your answer is correct, just type that correct or done, any one of you, so that we can go for the last question. Alright, Vidya has done, Dian Sophia has done, Daniel has done. Amma, Daniel, Joanne, Alex. Alright, so I hope all of you have get this answer. The idea is very easy. You can see as you do the exercises, you get the idea. Okay, last one is easy. Question 4 is easy, very easy. Question 4 is easy. I want you to try first. Question 4 is very easy. Try first. So let me give a notation here first. Maybe S is smoke, non-smoker is N maybe, and he has lung disease. I put disease here. Okay, disease. This one is no disease. A bar. Maybe I put a no have. I put a bar here. He does not have lung disease. So D bar. is, this is a notation, D is disease, S this is N. Okay, with this notation you try to find the answer here. Very easy, this one very easy. You should get the answer. Try first. Alright, this should be the easy one. Okay, he is a smoker. Okay, this is very easy. PS, PS you just plus this one. Okay, plus this one. So what you get? You should get 0.31 if I'm not mistaken. Let me check. 0.31.
Yes.
Good. He does not have lung disease. Does not have lung disease. You plus this one. That should be 0.19 plus 0.66. Okay, that is 0. This is D bar. D bar. That should be 0.85. He, question C now. Question C. He has lung disease. Okay. Given he is a smoker, so he has a lung disease. Given that he is a smoker, so P D intersect, this one will give you D intersect D and S here. Okay, 0.12 and S just now was 0.31. That answer should be 0.12 divided by 0.31. You will get 12 over 13, and the question D here is given does not smoke. Does not smoke is D bar. He has a lung disease, right? Oh, does not smoke. Does not, no, non-smoker here. Sorry. Does not smoke is N here. Okay, does not smoke. He has a lung disease. That is D here. And then D and N. D and N is here 0.03 and this one is 1/23. I suppose, is this the answer you guys get? Can you guys confirm with me? Anybody? Any problem? Try, check, anything, anybody? Say correct or done, something like that. Just double check. Alright, good. Some of you have done. Confirm. Alright then. I'll give couple of minutes for you to copy. Anybody want to copy this? Copy first. Right, I will share this. Okay, just give me some time. I will share also the YouTube link. So we will end up here. Next week is a Raya week. Okay, I don't want to disturb you guys. Some of you still on leave. Okay, the whole thing. Just enjoy your holiday, or enjoy your Raya for Muslim, and those who are non-Muslim, enjoy your holiday. I will upload some recording in the YouTube. I will send the link. For those who are free, you can see the link, and then we'll see how it goes. And after Raya week, we will meet each other face to face. Okay, then I think after that, after face to face class, we can go a little bit faster. With we have 4 hours. Okay, our class start at 8. Sometimes depends. If I will update you whether it's 8:30 or 9. Hopefully I can start with 8 to 12, but in between I will give some break for you guys. Okay, all right, with that, thank you very much. I'll see you all not next week, next week. All right, take care then.